friend.
Okay, welcome to this talk on data grids and WebSockets. The way it's going to work, I apologize for the screen isn't on full screen, but it's because I need a VM in a minute. So I'm not using PowerPoint. So what we're going to do is I'm going to do a quick 10-15 minute intro into WebSockets and data grids. Then I'm going to introduce, guys on the panel can introduce themselves, and then we've also got a demo. But that should take about 15-20 minutes, and then it's up to you guys, because this is a BOF, to ask questions of the panel. Okay, it's not working. Why is it not working? Okay, so I'm Steve Millage. I'm from C2B2. We're a consulting company on data grids and middleware in general, mainly around scalability. And we've also got on the panel Nikita Ivanov, is that how you pronounce it?
That's correct.
From GridGain. He is there. We've also got Greg Luck from Terracotta EH Cache, is that correct? Or Software AG, as it is now?
Terracotta's fine.
We've got Manik Satani from Red Hat and Infinispan. We've got Dave Felsi here from Oracle and Coherence, and Talib Ozturk, is that how you pronounce it? From Hazelcast. So we've got a very great panel, and I appreciate them all spending the time to back me up on this. So, like I said, we're going to look at a bit intro into WebSockets, a bit of intro data grids, a demo, and then each panel member can have a couple of minutes to introduce themselves, and then it's open questions. Okay, so if you look at the standard HTTP model, HTTP is request response, client requests data, server responds. The problem when we want to use push technology, so we're talking about sending data asynchronously down to the browser, is that HTTP doesn't really fit. HTTP's request response protocol is half duplex in the sense you can send data one direction and then respond. It's also stateless, so if you do polling or whatever in HTTP, there's a lot of redundant data on the socket. There's a lot of headers, lots of cookies, lots of overhead. And you occasionally, depending on whether keep alive, etc., new connections are required for a lot of traffic. There's currently ways of achieving or mimicking push on over HTTP, all of which are really a bit of a hack. So you have polling, where you keep an HTTP connection open for a period of time, waiting for the server to respond with some data. Long polling, which is you keep the connection open for a long period of time, taking multiple responses. Or you can use various browser plugins. So a lot of our customers in the sort of gaming area will use Flash and open sockets through Flash or through Java or any other browser plugins. So that's all going to change with WebSockets and HTML5. So what WebSocket allows you to do is to establish essentially a dedicated socket to a back-end web server, which is a brand new thing that you haven't been able to do before without a plugin. And that socket will enable full duplex communication between a server and a browser. And it's a raw socket, so you can, well, it's almost a raw socket, but essentially you can send and receive whatever protocol you like over that socket. So you're not using HTTP, so it doesn't involve HTTP headers. And that will allow web servers now to natively push data down to the browser. Okay, so that's better than long polling, as it won't keep connections or threads or open on the server side. It will reduce the data traffic, the volumes, data volumes. And the API is actually very simple. So this is the WebSocket API for HTML5. As one of the other talks said, HTML5 is more of a JavaScript spec than a HTML spec. So there's essentially, you open a socket by calling a WebSocket constructor, give it a location, which is a URL, give it a protocol, which is a bit of an opaque string, really, so it allows the server to decide how to handle it. And then In JavaScript, there's 4 callback methods that you add, which we'll see in some code. So it's on message, on open, on close, on error. They're callbacks that the browser will give you to your JavaScript when a message is received, when there's socket opened, when it's closed, when there's an error. And then the 2 functions that you can call are close and send. Okay, so that allows you to close the socket to the browser, and send allows you to send some data. And that could be byte arrays or strings or whatever. So it's quite very simple protocol. So this talk is really around both data grids and WebSockets. Most of the panel here, as you probably noticed, are data grid experts, not WebSockets experts. So the BOF is about using data grids to push data down. So this is what a typical data grid would look like. Okay, a data grid is a whole bunch of JVMs with objects in memory. The objects will typically have duplicates for high availability. The idea essentially being that you can scale out the number of amount of data you can store in memory by adding more nodes into the cluster. Okay, and that gives you an HA data store. The feature we're interested in today is events. So most data grid technologies and JSL 107 has a concept of a cache listener. And what a cache listener does is when you have a data grid like shown there, so we have a cluster with 4 nodes, and each one has data in it. When data is updated into that cache, then essentially an event can be fired to a listener on the cache, and that listener can do whatever it wants, and which in this case will be to send data down a socket. Okay. So JSL 107 has an API to attach listeners to a cache using register cache entry listener. And that callback is called whenever an entry expires, is removed, updated, or read. So what we can do is we can pull all that together to essentially hook those events into WebSockets to push data down to browsers. So back up that. So what we're going to I'm going to show a little demo and then open it to these guys to give an intro to themselves, what their thoughts are. So the demo architecture is we have a bunch of JE cluster nodes, which in this case, well, we have one, which will be Glassfish, enabled for WebSockets. As data gets pushed into the grid, then an event will fire, and a WebSocket, data will be pushed back down the WebSocket to the browser. So I'm going to show a little bit of that for 5 minutes. So the demo I'm going to show, I've got a tutorial session on Thursday which will take you through writing all the code for 2 hours, hopefully. So if you're interested more in the code, then I would come along to that. We haven't got time here to dive into the code too much. Okay, so the demo, if it works. So the demo is going to show a updating stock price in a Chrome browser. So essentially what we'll see is we have a graph of a stock price. It's not doing anything. This is an HTML5 graph, so it's not Flash. So there's no Flash plugin in here. This is pure HTML5. It's using a semi-open source library called HighCharts, which isn't actually open source, but it's free for non-commercial use. And so this is rendering using a canvas. We have a piece of code here. I apologize for some of the panel members. This is running incoherence, which is just going to push a stock object into a cache. Okay. On the WebSockets and in Glassfish side, this is we have a listener, a map listener. So when our socket gets connected, we add a map listener onto the cache, and then when we get an entry, we send an update, and that update if I can find it. Essentially takes a stock object, uses JSON. So the JSON library built into Glassfish, which is Jackson, and marshals the stock object into JSON and then sends it down the WebSocket. Okay. So if I refresh this to make sure it connects, and then if I run this standalone Java process, which is going to push data into the grid, so we'll see it starts connecting to Oracle Coherent, so it's connecting to the grid, and then it starts pushing prices. And you can see in the Glassfish server, which is receiving the data.
Coherence bug?
Yeah, it ain't working, is it? Oh, I knew that would happen. Right. That always happens. Let's restart that.
Your bug.
No, it's demo god, isn't it? So I restart Glassfish. I think my socket had timed out. So essentially in the server initializer, it's getting into the cache, so we saw some coherent stuff. If I run this again. So you can see, basically these are real-time updates being pushed down to the browser and getting rendered in real time. So it's not using Comet, it's not using long polling or any other technique. If we stop the grid updater, we'll see that data stops. If we start the grid updater again, you'll see that data starts flowing again. Okay, so that's just really to set the scene of what's possible when you hook up data grids with WebSockets. So what I'll now do is pass over to each person in turn. They can spend a minute or so saying, what their thoughts are, what their product's direction is, whatever they like. I'll give you a couple of minutes each, and then we'll open the floor to questions.
Okay, thanks, Steve. So it's interesting. I've actually been looking at this stuff recently. What we're planning on doing. So with Terracotta, we really don't support anything less than a server client. You have your Edge Cache API and Terracotta Toolkit, which connects to the Terracotta server array. We support up to about 1 terabyte of memory in there. It's quite heavyweight. That client's meant to run on your application server. So we've never really had anything suitable for desktop or for mobile or for HTML. We're changing that, so we've got a new project that we kicked off a few months ago. We're adding a Terracotta communication server that's going to be based on the Nirvana code base. Nirvana is a high-speed asynchronous messaging system that Software AG acquired about 6 months ago. So the Nirvana team are building this. What we're building is we're building cache clients based on asynchronous messaging for a whole array of things, including HTML5. And for HTML5, it will use WebSockets. So I see it a little bit differently to what Steve has here. Steve's basically putting this together using cache event listeners. What I think we'll have is we'll actually have a cache API expressed in each of the various things. And so for the browser, it'll actually be a JavaScript cache library. And so you'll be able to specify what size you want. There'll be local listeners on that cache library. So what we are building is relevant to this is actually a JavaScript caching library to allow tens of thousands of browser connections through to a new component which will be called the Terracotta Communication Server based on the Nirvana code base. The Terracotta Communication Server itself will actually be a heavyweight client of Terracotta, just like app servers are today. So it will hold up to, a terabyte or so of data in memory. So there'll still, most of the time, be a single hop from the browser to the Terracotta Communication Server, or the Terracotta Communication Server will be receiving changes and it'll just be naturally pushing, but it won't be doing it via cache event listeners.
Okay.
In Coherence at the moment, we do have sort of extend clients, thin clients that connect via proxy to a cluster. I mean, like Greg said, I mean, we're exploring things to do in this particular area, and what you describe sounds a sensible way of doing it, having basically exposing an eventing mechanism where you have a JavaScript client library. We have customers using Coherence with a large number of extend clients, which are basically thin clients, not thin clients, but clients connecting into a cluster which aren't part of the cluster. So in terms of scale, we have customers with up to 10,000 clients on large compute grids accessing Coherence cluster. I think that's not necessarily the way you would do it with WebSockets, because you would, I think you'd be connecting into a cluster and receiving events from the actual cluster members. So we're doing similar things at the moment, but we're not actually doing a WebSocket eventing mechanism. We provide a REST API, but that's pull, it's not push. One thing that's happening in the Coherence space is there's a closer alignment between WebLogic Server and Coherence. So in the next release, we're looking at bringing the two together. So you could push events down to clients through a WebSocket API in the same JVM that the Coherence cluster members are actually running in. So you wouldn't have any kind of hops to go and fetch the data to push down. But I can see this being very useful in the sort of gaming space and things like that, where you want that kind of real-time events being sent to clients who are running sort of thin browser applications. It's certainly got a lot of appeal in that sort of space.
My name is Talib. I'm the founder of Hazelcast. With 2.0, we try to address the big memory part of the new era, big data era. With version 3, we want you to be able to develop your own data structures. So if the data structures that we provide, the maps, multi-maps, queues, if they don't match your needs, so you'll be able to develop your own distributed data structures on top of the framework that we provide. I have a talk next to this session on Hazelcast downstairs. Coming to this WebSocket thing, Hazelcast socket can understand HTTP right now directly without a facade. This was done for supporting HTTP REST calls. We then started thinking, what will happen when we have the WebSocket thing? Can we convert everything among all the Hazelcast communication? Can we convert everything to WebSocket communication and things like that? Eventually, we decided not to. It doesn't add value to the to our case, because most of the time grids are going to be running in a local network. And so for the demo like this one, I always think that a browser should not be directly talking to a data grid with a JavaScript library or anything like that. It should never, because I shouldn't say this like this. Maybe I should say low latency connections are not good for data grid. So I would avoid every high latency connections to data grids. So I cannot imagine having, like, I don't think you should be having a web browser with a high latency connection to the grid, connecting directly to the grid and writing from the grid. I think there should be a facade in between so that you can tolerate or arrange the low latency, high latency traffic. So everything inside the data grids should be super fast and optimized. So that's why I think data grids should be there should be a facade in between when it comes to browser remotely connecting to a grid.
Okay, thank you.
Everybody, my name is Akira Ivanov. I'm a founder of Gigain Systems. So we do in-memory data platform that allows you to store terabytes of data in memory across multiple computers and compute and process across these large data sets in real time. So when it comes to WebSockets, I mean, I'm kind of on the sides here. For us, the way we're actually working right now on that technology, for us it comes on the side of client's connection to the Grid Gain as a data platform. We have a number of connectivities right now. We're Java-based products, so Java, Scala, and Groovy are native languages to us. And we have various clients that allow it to legacy C++ or .NET or Memcached or REST application connect to us natively. And when I say natively, we support full affinity collocation on all of those different languages. So something we've done recently, we added the Objective-C for mobile devices and Mac computers. And we're currently working on the JavaScript client. Again, we have a full affinity collocation built in that. And the protocol for that is the WebSockets for us. But again, I would side with the Hazelcast folks that, I mean, in real life, I'm hardly seeing anybody connecting directly from a browser to a freaking grid. You got to have something in between. I mean, departmental applications, I can probably see it somehow that if you have a small grid and it's just, a few dozen users, you can connect directly from the iPad, from iPhone, or from browser. On any different scale, you never connect to grid directly. You always have some intermediary between that. And I mean, look, we had Comet for a long time, and that gives you pretty much the same functionality as a WebSocket without standardization. And it's a cool stuff, but again, across our clients, if you're looking across, we have about 1,000 different users using us in companies. I can probably find maybe, on top of my head, maybe like 5 or 10 companies that I've heard of actually utilizing something like Comet, and right now maybe WebSocket. So I'm kind of on the sides here.
Okay. Hi, I'm Manik Surtani. I'm the founder of Infinispan, open source data grid. Interesting stuff that you guys have been saying, and I kind of agree again with both Nikita and Talat about the relative value of having high latency connections into a grid. That said, Infinispan can be accessed in 2 different ways, a bit of architectural work here. It can be accessed in VM, that's its primary mode of operation, but we also have client-server connections into the grid. The way we built that, I mean, this being open source, the way we built that was around a lot of open source connections, which means very extensible. We primarily support 3 different protocols, REST, Memcached, and our own protocol as well. But someone has actually contributed a WebSockets endpoint for Infinispan, and that actually is there. It's an experimental thing. I don't actually know who uses it in production or why, but it does exist. You could, in theory, do that. That comes with a JavaScript library again, so kind of you load that up in your browser. You're directly talking to the grid, you could do that, attach listeners to it. But for me, that's a little bit less interesting than another interesting part that I've been playing around with recently. And that is, at least from what I've seen, people don't tend to write WebSocket code directly. They tend to use libraries, right? Everyone uses a library to generate this stuff for you. You're not directly wiring JavaScript yourself. So one very interesting tool, at least for Java developers, is GWT. And there's an interesting framework called Arai, which generates a lot of WebSockets-based code around GWT. Now, Arai is CDI compliant, which means it runs in a Java EE server in a standard way with injections and everything else. And what I find interesting is the work that we've done on JSR 107 and the annotations we have for distributed caches and data grids, which tie into CDI. Which means that if you have a CDI compliant library like Arai that is generating WebSocket code for your browser, just with simple annotations, you can now tie that up and wire that to your data grid. That, I find, is actually quite interesting and a more interesting way things might go. Yeah, well, I'm actually doing a talk on that tomorrow, so if anyone's interested, come by. I've got a bit of a demo as well.
All right, so have we any questions? No one? Go on then.
Just wondering what the use case using WebSocket is connecting directly with data. Because if you talk WebSockets, you've got quite a few issues going through proxies, for instance, not really compatible. So there's, connectivity issues beyond 3G. You just go around the corner of a certain building, and maybe switches, the latency aspect of it, we understand some of the customers they have issues with it. So what needs to be implemented is basically fallback mechanism between WebSockets to fallback just so in terms of JavaScript library, we need to support all three of them. And as soon as we can handle that, I think we want to express a lot of pain on the data grid side. We connect it.
Well, if I can take that, what I mentioned about using libraries again, that's where you have the layer abstraction. So something like Arai will actually generate different pieces of JavaScript for different browsers based on your browser capabilities. And then if you're tying it in again using CDI into your data grid, you don't have that problem anymore. That's abstracted away from it.
Can I just jump in here, because probably of the panelists, I'm probably the kind of sound like I'm the most pro this. The reason is that a lot of these ideas came from the Nirvana guys. So the Nirvana guys, basically Wall Street, London trading systems, they for 10 years have specialised in last mile. So they have all the different client libraries. Now, they're a messaging, sort of like a last mile messaging system. They have this feature which is called registered events, and essentially it's a cache. Now, the use case is that you have a trading desktop, and there's changes to price and so on that's actually happening, and you actually want to push that to the desktop. Also, when a new desktop connects, comes up, you want to connect and actually get the latest values. So they call it a last value cache. And I looked at this registered events thing, I'm like, you know what? This thing is basically a cache. So they have just about every one of their customers actually using this today. And it's essentially the same. The existing Nirvana HTML5 library is already in the process of being changed over to WebSockets. So the Nirvana stuff with registered events, which is a type of cache, they could easily be sitting here as a panelist basically, is actually doing this today. So what we're simply going to do is basically connect it to Terracotta. So instead of Nirvana getting into the caching business, we'll basically use their stuff, connect it up to Terracotta and EH cache. Now I think the use cases for this will be the same use cases that they've seen. So I don't know if it'll be authenticated users. I think it'll be trading applications, and it'll be things like that. Probably with hundreds of connections, but I mean the technology should permit tens of thousands. But I don't think you'd want anonymous, unauthenticated access into your data grid.
I'll just jump in. Actually, in the demo, it's probably not clarified here. We're not actually connected direct to the data grid. We're connected to Glassfish. Glassfish is connected to the data grid. What we're leveraging is the events capabilities of data grids to push in real time to Glassfish updates that are occurring, and they're getting pushed down the WebSocket via Glassfish.
But in Nirvana, you actually connect directly to the Nirvana server, including across the web, using HTTPS. And like you might go through a load balancer, but it goes directly to Nirvana. And the way we're designing this thing, you'll be going directly to the Terracotta communication server. It's kind of is like a gateway, I guess, rather than raw into our grid, but it's still direct connection to one of our servers.
Yep.
There are a number of different ways of architecting it if you wanted to stream events from a data grid. I mean, it obviously depends on the particular technology and depending on the terminology, but for coherence, for instance, if you wanted to access a coherence cluster from a thin client from a .NET, C++, Java client, and you are outside of a cluster, say you're on a compute grid node, then typically you go through a proxy, which is basically passes requests on to the rest of the nodes in a cluster. I mean, if you're making, say for instance, the application server part of the cluster itself, you could do that. You could make it a proxy, so you could pass the requests on to other nodes in a cluster. I think with security and things like this, I mean, the layers of security you need obviously depend on whether it's public facing or it's internal.
Sure.
But you know, a lot of application servers have a ton of security features they can add in themselves. So you know, basic authentication and obviously a lot more complex ways of actually authenticating clients. I think the actual architecture in terms of who the clients are actually directly connecting to will just depend on the level of security and isolation you want to put around your data grid.
I agree with that. Look, Nirvana's been doing this to the internet for 10 years. So they've got all security built in. You've got to deal with it. I think there's an interesting point about this example. The way Steve's framed it is event-based. Now, the way you've done it, Steve, is great for a stock ticker. But what if actually what they want is a list of prices? So 150 stocks and prices. And when in the event model that you've got, you'd basically start up the application and you'd have to wait for a trade to happen before that particular stock would get updated. Turns out, I think the actual use case is when you connect, you actually want to go and grab the last value for each one. So you can't, that's why I don't really think that you actually want to use an eventing model. That's why I think that what you really want is actually to extend the cache of the data grid client directly to the browser.
I think the first JSP would get those values and then connect back for the eventing.
Yeah, but you'd have to do all that manually yourself.
Yeah.
You'd go through each of the stocks and you'd basically do a call. Or if you're using a cache client, you'd simply connect to it and it would all be there because it would actually just bootstrap in as soon as you connect it.
I mean, the use case we see in Europe, which you can't really see in the US, is for gaming, online gaming, for in-play betting, where you're getting price updates or odds updates on games pushed to people's browsers in real time. At the moment, they're using long polling, which uses significant resources in their environment, and for them, bandwidth is expensive. And if prices are out of date even by a few seconds, then people may not place the bet. So it's similar to the stock model.
It's just how much work you want to do as a developer.
For this kind of architecture, the load balancer and the application server, it seems like it will be very expensive because you need to keep the connection alive all the time. If you have a lot of active users, how you want to scale that out and try to save money on it?
I mean, that's something that the vendors are going to... I mean, WebSockets is in HTML5, so it's a socket. You can't create many sockets for each browser. You have Keep Alive now, so I don't see that it's a huge difference. If you use Comet or anything else, you're keeping a socket open.
Yeah, but the whole idea of having like a stream API or this kind of technology can enable another set of technology. That's basically the web. It's in a publishing model. But once we have something like this, people will try to get massive amount of data on the page as fast as possible. And I don't see how that could be possible with a massive amount of money to have that connection.
I mean, I think the Java app servers sort of changed their architectures over like 5 or 6 years ago from one thread per request to like the NIO style, where you like a Cedar architecture, where you configure, you can have tens of thousands of connections, but just in a pool of threads that are actually servicing those requests. So a sequenced event-driven architecture. I think they've all changed over to that. They all have to, for other reasons, they've got to cope with a large number of concurrent connections. So I don't see this as adding anything too new.
Yeah, I mean, that's how most servers end up working today anyway. Even if you're building a custom server, or if you're building it on top of something like Netty or whatever, you end up doing NIO or NIO2 nowadays under the covers. So when using Infinispan as a server, for example, it's all built on top of Netty, and you get essentially a lot of asynchronous I/O.
So don't confuse sockets with threads. So threads are not blocked in sockets. And sockets you can...
How come is that ringing? It's actually on silent. It's still ringing. It's actually on silent. I think the switch is a bit buggered.
Connection directly to the load balancer to the app server. But what if you have 10,000 users? You will have 10,000 dedicated sockets.
Sockets are fine. Sockets, so you can have as many sockets as you like.
As long as they're dedicating one thread per socket.
Yeah, as long as it's below 64,000. So, yeah, you're going to have a thread pool, imagine this, thousands of sockets, and then you spread over and then you basically scale out horizontally. So every box can handle tens of thousands. I mean,
I think it's a solved problem. I think it was solved 5 years ago.
Yeah, you have that problem with Keep Alive now. So
HTTP 1.1.
Yeah, most of the modern web servers are already trying to fix this 10,000 connection problem anyway. So even one server can handle that.
Yeah, there's an old website actually. It's called the 10K.
10K.
The 10K problem. The website. There's a website called like 10. What is it? 10K. 10. What is it? C10K. C10K. Like, this website's 10 years old. Like, people have been working on this problem for a long time. The Java App Server community, as I said, I think they pretty much all changed over. I used to use them back when it was one thread per request and it was problems, and that's long gone. Now it's just about now it's really just about configuring the pools. So just tuning your pool sizes so you can actually service the number of requests coming through.
Yeah.
Web server or the server engine already supporting WebSocket?
Servlet engine, I can know some. So if anyone knows others,
Are you referring to just support, or are you referring to a standard?
Okay.
well, to the latest RFC, I think. I mean, Jetty does, Tomcat 7, Glassfish.
Tomcat 7, yeah.
Yeah, you have to be careful which one, but the very latest supports WebSockets. This is running on Glassfish 3.1.
And there was also a proposal to get that into a Java EE standard so that
We'll do
applications can
everything
access
No,
WebSockets in a standard way. But that, I'm not sure of the status of that.
Because the normal server is that you have to register somehow, and then the control is going to give it to the server to process. So in this case, is that after the socket upgrade to WebSocket, so just a pure socket connection, then how does it, since I'm new to this, so I just wonder how would that work? That, so for example, because the socket itself is just a native, it's a native protocol, only the client and server understand how to handle that. So how would that work in this case?
I get the question right. It's because both client and server I've written by myself, so they understand the data that's going across the socket, but it's opaque to the Glassfish.
Yeah, but that's kind of where I think it, that we plan to provide a client library. It won't look much like the current Java one. It'll be much more simplified, but it's kind of, I think that's an important simplification.
Yeah.
Okay. So kind of based off the first part of the thing you said, so like if you're running Apache front end, to handle that same level of open connections, you both Apache.
I have to be honest, I don't know whether Apache supports WebSockets yet. It might do, I don't know. So I don't know if anyone else knows. Sorry.
My question is about the database rather than the WebSocket, and I've been involved in way too many database product evaluations, and since we have 5 product experts here, I'm hoping if each of you can talk about one feature that your product outshines all the products, if that's possible.
Well, I'll just go in first. I mean, what you need to do is get a consultancy like ours to come in and do your evaluation for you.
I don't think it's.
But anyway,
I don't think it's a good use of the panel's time for us to sit here and blow our own trumpets.
I agree, actually.
Yeah. So yeah, you need consultancy.
But surely if you've done evaluations
That's
already,
where you go
know
to the booth
them,
and get the essays to talk to you.
In the use case that's presented here, where it's basically kind of a passing-based architecture, what advantage does the data grid give me over something like pops up or message box?
Okay. Do you want me to take? I mean, my view is it's much more lightweight. You can add event listeners onto a data grid, and they can have filters associated with them, so you can get a subset of the data you're interested in. So you don't need to set up any queues or anything like that. It just be, in this case, when the connection is created, it creates a listener on the cache for that specific connection.
Can I?
Yep, sure.
Once again, I don't believe that like using cache event listeners tend not to work very well with most data grid implementations anyway, in terms of high volume. The only reason that this demo has been done with messaging is because us vendors don't currently have HTML5 WebSocket cache client, and I think that's what needs to be built. And then you don't need to worry about how it works under the covers. You just have a simple JavaScript API, and there you are.
No, I agree with that.
Yeah, so obviously a common thing that I think all of the vendors out there support is storing HTTP sessions and distributing them across the data grid. Given that WebSockets are a stateful, like a truly stateful connection, do you guys, or are there any plans to support on any of your data grids the state that you need to scale WebSockets out across multiple servers? I mean, to give you an example, this example we're looking at here wouldn't scale to multiple servers because the client has a discrete socket connection to that individual server. Now, if you need to scale to 1,000 servers, you need to maintain a very different type of state across all the servers.
I mean, before I jump in, I think it would scale out because you would just be adding additional cache listeners, but you'd be load balancing across Glassfish clusters.
No, your WebSocket client here is connected to one individual server, and because it's a true stateful connection, it doesn't do another subsequent request that might hit another server in your pool of servers.
No, but your load balancer would spread it.
Yeah, I don't see.
There's no new connection here, so you're not going to be going.
Yeah. Well, hang on.
If it fails over, WebSocket protocol has reconnect built into it.
Okay, but say you've got, say you get your event listener and you're listening to one type of stock in this example. How do you know which clients connected to which servers are listening to which stocks and should be notified of which event?
Okay, I'll let these guys take it.
Well, firstly, if you're connected to a data grid, it doesn't matter what node you're connected to, you'll have the same view of the data more or less depending on the consistency model that you choose. So I don't think it really matters if if let's say the socket closed and you reconnected to a different one. I don't see how that matters, right? The other thing is that on a scale out, at least in the architecture that I'm planning, Terracotta communication server, you can have N of those, right? You have a load balancer, you always connect through a load balancer, and then the load balancer, you can choose your strategy, I think round robin or whatever. It just basically will choose between them. And so if you need to add more, each one will be rated for so many. You want to add more, you just keep adding Terracotta communication servers. They're just clients of the Terracotta server array.
Yeah, but I'm not talking about reconnect. I'm talking about client A cares about Google's price changes, and client B cares about Oracle's, and they're connected through the two different servers.
Well, once again, this is just because this has been presented as events, and like what you're really doing, what you're saying is, okay, I'm interested. This guy's interested in this topic. This guy's interested in this topic. If you say forget that, and it's a cache client, then one guy might be interested in one cache or one another cache, or somebody might be interested in a certain cache key, or the cache client might be performing searches.
Okay.
So I think these problems are introduced by thinking about this as messaging.
Yeah. So you handle it in your client-side cache client.
Yeah.
What are the other guys got?
Well, that's pretty much what we do if we're not talking about WebSockets. So when you're using InfiniSpan as a remote grid and you're connecting to it, say, via Hotwire, which is one of our protocols, you have a client library for that. That essentially does exactly what Greg described, where you end up computing consistent hashes on the client as well, so you know exactly which nodes in the back end hold which pieces of data, and you're able to route your request accordingly. That could be done for WebSockets as well, easily enough.
But isn't that another subsequent connection? You keep that one single connection open the entire time?
Yeah, per piece of data that you need.
Okay, so you put that responsibility back to the client?
Again, yes. Yes.
Shard.
Basically, yeah. It's almost like an auto sharding or something that's going on.
Didn't one of the other guys say that you only just have one connection
per server? So if you're hitting two different servers in the back end, those are two different connections.
But I think the case that you're worried about is real. There are actually 3 production chat applications that I know of that are written on top of coherence. Right now, technologies which Oracle acquired is one of them. And another one was a coherence embedding in a third-party product, and then there's a third one that's a cellular provider. And they have this problem. So, like, if 2 people are in a chat, they're both connected to some socket endpoint, and then they have to reconnect, the notifications of new messages now have to go to a new place, and that has like a piece of state that's associated with the numbers.
Only if it's message
But
based.
it's a real problem.
Yeah, and I think the reconnects example is actually a bit easier. I think the other ones, when they don't have the reconnect and they maintain the connection, you now need to know which of your 100 servers is connected to that one user. So say you've got a piece of data you need to push to this one user, which
Where
one
you
of
send
the
it,
services
yeah.
to go to has that connection. It's just a different type of state. And I think the HTTP session replication has been well handled by all of you guys, but I just wanted to know if there was any plans there.
I mean, one of the key things is most of the products allow you to place a filter, so it's not, and those events are then delivered to wherever that listener is that matches that filter. So the state can be set in the filter. You don't have to sort of filter, send it to everybody. The callback goes to the guy who's got the listener with the correct filter on.
I have a question for the panelists.
I think got 1 minute. So.
There's a risk with this kind of integration. If any of the send calls of data down the WebSocket to clients are slow to respond, it risks piling up unreceived messages, somewhere in the architecture and exhausting resources. But we've seen this in grid-based applications without WebSocket. So I'd like to know from the panelists their thoughts on the severity of that risk and ways to mitigate it in your project.
But it's a typical back pressure situation. There is no magic here. Somebody has to have a valve and control the back pressure. If it's a client, like a JavaScript fine, it's going to be client. Because it's a lot easier to control on the client because you know your logic.
I mean, try logic control, you can back off and come back again.
Exactly. So there's.
So in a system with a high event rate, the grid is eventing to a WebSocket, and if the WebSocket can't send the data fast enough, there's a queue building somewhere.
Yeah, on the client typically, and that client will then be able to either time out certain requests and retry or something like that.
I'm thinking it's in the server that's sending data down the WebSocket.
It could be some back pressure. Yeah, I mean, again, when it comes to back pressure and handling the back pressure in there's no magic. Somewhere somebody has to drop the message somewhere and report back to the client that actually now not the client, but actually some server-side code to throw exceptions and say, hey, I cannot send this message anymore if I filled up my buffer or something like this.
Okay, I think we're actually out of time, so sorry.
All right.
Thanks very much.
Thank you.